Hey everyone, and welcome. Today we're going on a pretty wild journey, tracing the story of algorithms, from what were basically simple sets of rules, all the way to AI that can, get this, actually write itself. So let's dive right in.
I want you to keep this question in the back of your mind, because what we're talking about here is a fundamental shift. We're going from the ancient world's ideas of logic to modern AI that's doing things we never imagined. The bottom line is, algorithms aren't just following our orders anymore. They're starting to learn, to adapt, and yeah, even to create all on their own.
So, to really understand where all this is heading, we've got to look back. I mean, way back. Our story doesn't start with computers or silicon chips, but with the simple, powerful idea of a repeatable, logical process.
Now, what's so fascinating here is how you can see the thread connecting pure logic to actual machines. It all starts with Euclid, right? He gives us a formal way to think, step by step. Fast forward a couple thousand years, and Blaise Pascal actually builds a machine to automate one of those steps, calculation. And then here comes the big one. Babbage designs the hardware, the machine itself, but it's Ada Lovelace who sees what it could really do. She got that it wasn't just about numbers. You could use it to manipulate any symbol, letters, musical notes, you name it. That was it. That was the birth of the idea of a general-purpose computer. This is the foundation everything else is built on.
You know, before we even had the word algorithm, people talked about an effective procedure. And this term just nails the core idea perfectly. It's basically a recipe, a simple, totally clear set of instructions that anybody or anything could follow and get the exact same result every time. This concept, this is the soul, the DNA of every piece of code that has ever been written.
Okay, so let's jump ahead to the 20th century, because this is where things really take off. This is the moment where all those philosophical ideas and clunky mechanical dreams just ignite and start to change, well, everything.
You might have heard biologists talk about the Cambrian explosion. It's that period in Earth's history when life just suddenly diversified into all these new, crazy forms. Well, the mid-20th century was the Cambrian explosion for code. All of a sudden, these theoretical ideas had a place to live, the computer, and they just started to evolve at this unbelievable, breathtaking speed. And this era gave us the toolkit that our entire digital world is built on. We got languages like Fortran and COBOL that let us talk to computers in a way that was way more natural. We had these huge efficiency breakthroughs, like Dijkstra's algorithm, which figures out the shortest path between 2 points, something Google Maps does for you every day. And then came the algorithms that could manage huge databases, the ones that secure your credit card online, and of course, the ones that literally built the World Wide Web.
And that brings us to the next great leap. This is the moment, the real turning point, when algorithms stopped being just passive tools that followed our instructions to the letter and started becoming systems that could actually learn for themselves.
So this distinction is absolutely crucial. A traditional algorithm is like a super detailed recipe I write for you. Add exactly 200 grams of flour, then crack 2 eggs. It will never, ever deviate from that. But a machine learning algorithm, that's more like me giving you a fully stocked kitchen, showing you 1,000 pictures of a perfect cake, and saying, you figure it out. It learns the patterns itself. And that's the fundamental power shift, from human-written rules to machine-discovered patterns. The programmer isn't a micromanager anymore, they're more like a teacher, or maybe a librarian for data.
So how does it actually learn? A lot of the time, it's through a loop that's as simple as it is powerful. It's called reinforcement learning. Just think about AlphaGo learning to play the game Go. It tries a move. Did that move make it more likely to win? Great, that's a reward. So it updates its internal strategy to make more moves like that one in the future. Now just imagine it doing that millions and millions of times. It just keeps repeating that cycle, getting better and better until it can beat any human on the planet.
And this whole learning approach has given us this incredible new toolkit. You've got neural networks, which are kind of like the digital brains of the operation, amazing at finding patterns in data. Deep learning is just when you use really, really big neural networks to tackle super complex stuff. It's what changed the game for recognizing images and speech. Then you have crazy stuff like GANs. Think of it like a game between two AIs. One's an art forger trying to paint a masterpiece, and the other is a detective trying to spot the fake. They both get so good that the forger starts creating art that's totally indistinguishable from the real thing. And of course there's NLP, natural language processing. That's the magic behind models like GPT-4, allowing them to understand and write like a human.
And this This is where our journey gets truly mind-bending. We've officially arrived at the point where these learning algorithms aren't just solving problems for us anymore. They're starting to design the next generation of algorithms by themselves.
Seriously, this isn't science fiction anymore. It is happening right now. We call it meta-learning, which literally means learning how to learn. Things like neural architecture search use one AI to test out thousands of different designs for another AI, automatically figuring out which one is best for a specific job. Think about that. We are building AI systems whose entire purpose is to invent and improve other AI systems.
The implication of this is just staggering. I mean, when your tools start improving themselves, you don't get steady progress. You get exponential growth. This could put scientific discovery into overdrive and maybe even help us solve some of those huge global challenges that just seem impossible right now.
So, as we're standing on the edge of this new reality, we have to stop and ask some very, very serious questions about the world we're building. Because this kind of new power, well, it comes with some profound responsibilities.
Each one of these is a massive challenge. First, there's bias. If an AI learns from our messy, biased world, will the new AIs it writes just amplify our worst prejudices? Then you have explainability. If an AI designs a brilliant new algorithm, but its logic is a total black box, so complex that even its creators can't understand how it works, how can we possibly trust it with critical decisions in medicine or finance? That leads right into AI safety. How do we make sure these incredibly powerful systems are actually aligned with what's best for humanity? And all of this points toward the idea of the technological singularity, that hypothetical moment when AI growth becomes so fast and uncontrollable that it changes human civilization in ways we can't even predict. These are the big, unanswered questions we're facing.
Which really leaves us with this final thought. For pretty much all of human history, algorithms have just been our tools. But now, as they start to learn, create, and even design their own successors, that relationship is changing in a really fundamental way. The future might be less about us programming them and a lot more about us collaborating with them to solve problems. And what that future looks like, well, that's a story that's still being written right now.